Good afternoon or good morning if you're joining us from a different part of the world. Welcome to today's webinar on obfuscation with SmartAssembly. My name is Leila Lotfi. I'm on the SmartAssembly team here at Redgate Software. And with me, I've got Chris Allen, our .NET support engineer for SmartAssembly, who will be presenting today's webinar. The webinar should take about the demo itself will last about 30 minutes, and we'll have a Q&A session at the end. And in order to provide a clear line, you'll be on mute so that we can avoid background noises. But we welcome your questions throughout the webinar. So if you have any question, please type it into your GoToWebinar console on your right. And at the end of the demo, we'll read them out and answer them. So please do type them in. I'll give you a very quick introduction to SmartAssembly just to put things into context. So SmartAssembly essentially does three things. It's a .NET obfuscator, but it also does automated error reporting and feature usage reporting. Now, this webinar is solely about the .NET obfuscation part of it. And just a quick preview on why it is that you should consider obfuscating your .NET code. So when compiling an application in the .NET framework, the source code you write, whether in C# or VB.NET, gets compiled into the intermediate language or IL. And at runtime, the IL code is passed through the just-in-time compiler, generating code which can be executed by the machine CPU. The problem is that the IL code you distribute is very easily decompiled back into the original high-level language it was written in, exposing the entire source code of your application to anybody who wants to see it. And obfuscation is simply an extra step at the end of your build process, which modifies your assembly so that it can't be decompiled. So if you're about to release a new application and you want to prevent malicious users reverse engineering your code or stealing your IP, then obfuscation is a must-have. Obfuscation is not the only way you can protect your code against malicious attacks, but it should be a key part of your IP protection strategy, and it's certainly the most popular one. Before we move on to the demo, I would like to pop up a poll just quickly to get an idea of how familiar you are with obfuscation in the first place, and that will help Chris determine whether he needs to spend more time on the more basic features or the more advanced ones. So I'm now launching a poll on your screen, which you should be seeing now. So if you could just quickly just respond to it so we have an idea as to what we should be covering. That would be very helpful. So I'll just give you 30 seconds to do that. Okay, brilliant. So it looks like about 60% of the audience is completely new to this. So we will spend a little bit more time on the more basic stuff. So I would say probably about 15-20 minutes on that, and then Chris will be covering the more advanced stuff in the later part of the demo for about 15 minutes or so. Brilliant, thank you very much. So with no further ado, I'll pass you over to Chris.
This is Chris Allen here from the .NET support team at Redgate. I also have a background in application security, and that's why I was chosen to demonstrate this application. Is explain a little bit more about what Leila was talking about when she explained why you need obfuscation, the reasons for that. Now, hopefully with me, you'll agree that .NET is a fantastic platform, probably one of the best things Microsoft have come up with in the development world. It has many benefits, but it does have some downsides, and the architecture that it uses in the security space does have this one downside, in that in reverse engineering intermediate language is a lot easier than reverse engineering native code. So what SmartAssembly, what obfuscators try to do is bridge that gap to a certain extent to make your distributed code effectively as hard to reverse engineer as native code. So let me just be clear on what I mean by that. This is the application that I'm going to demonstrate, a very simple application, and it's easy to inspect this application, this exe, in terms of looking at the intermediate language, which is what gets passed to the just-in-time compiler and then executes as native code. That's the fundamental architecture of .NET. So I've opened up my executable in Reflector, and what it's doing here, actually what you're seeing is not Reflector being clever in any way. It's simply reinterpreting the exe in intermediate language. It doesn't have to do anything very clever to do that, because assemblies are exactly just that, intermediate language packaged in some way. The clever bit about Reflector is the way it can take the intermediate language, and this is what it looks like in a method. The clever thing that Reflector does is just take this and then reinterpret it in a language we all know and love. As you can see, it does it in many languages. It's recently been updated with F#, so if you ever want to dabble in some functional languages, I recommend reverse engineering your own code and seeing it reinterpreted in that, but that's a side issue. I'm going to stick with C# because that's what I know and love. So I hope looking at this screen here, the disassembled version of my code, you can start to get a feel, if you don't already know, where the dangers might lie in your assemblies, which could well be distributed and out there. For a start, I mean, this is a very simple application. It's got everything in one method, and as you can see, it's actually got some sensitive data here. My Gmail account and password. That's not actually my password, but you can see that some structures take as their arguments sensitive data. So just very quickly touching on this subject, that your distributed applications, unless you give them some extra protection, could already be sort of leaking important data. So what do we do about it? Well, for a start, let me just set everything in context and show you what this application does, and then we can actually see a real example. Here it is, very simple Windows form application. Just at the moment, it's just hooked up into my own mail account, sending a simple mail. So sends a mail, and I'll just prove that it's actually working. There we go. And what I'm going to do is just prove that we can change the assembly, protect it, and it will still work just as intended. And this is my actual code. This is my real password here, so I've hidden it. So going back to Reflector, just to prove that what Reflector has done is correctly interpret the assembly, taken this intermediate language, and has very accurately reinterpreted it into the real source code. This isn't by any means a perfect system. There are some different types of structure that can cause reverse engineering problems. Things like yield statements, things like that. So it takes a lot of effort sometimes to get back your full source, and what obfuscation does is just make that job very, very hard. So only really the professional hackers end up with any clue as to what's going on. It easily defeats script kiddies, people like that. So the first thing I'm going to do, because you may well have this exact need in your own distributed code, is to show you how to get rid of those strings in clear text. And by doing that, I'm going to show you how to start your first very simple SmartAssembly project. So I've opened the project up, And the way it's designed is to be as intuitive to use as possible, so there's no nested menu options. Everything, what you see is what you get here. And on the left here is the main project management options, and along the top are your visual clues to the features that I'm going to show you how to use. So let's start up a new project. And it's really a simple case of browsing to the exact assembly. And in this case, it's a Windows form application, so it's the executable that I'm interested in protecting. I'm going to go on to talk about your dependencies, whether they be third-party or not, and explain a little bit more about that. But I'm going to try and keep it simple to start with. So we just pick up on my executable. Okay. And SmartAssembly is intelligently prompting me for the next thing to do, which is where do I want to put this assembly when it's been protected. What I recommend is never change the name of any of your assemblies if you protect them. Just put them in a folder immediately adjacent to your built assembly. That's really what I do, and I haven't found a problem with that. Whereas there will be problems sooner or later if you start changing the names of your assemblies. As I say, there's, as you can see also, that there's many different features that SmartAssembly can deal with. Most of these are about protection of your IP. Some of them are about enhancing your assembly, making it use less memory, that kind of thing, packaging resources. But most of these are all about protection. You don't by any means have to use all of them. Obfuscation is a little bit like an art, really, in that you will try to use as many features as possible, but finding exactly where the optimal line is can be a little bit of an art. So by all means experiment with different features. I'm going to show you really just the absolute essential features that you'll want to use with every project, and later on some advanced features. But the essential ones start off with strings encoding. This is going to get rid of all our strings in plain text and just hide that any sensitive data that you may have forgotten about. It's a simple case of selecting this button and then, for simplicity's sake, simply choose all the other options. There's just one with improved protection, compressing and encoding the strings, and caching strings. I just recommend you use all those defaults. And as you can see, this little yellow bar has changed to green. It's another feature of SmartAssembly where it's giving you these intuitive visual clues that your application is becoming more protected with time. So let's see exactly what effect that has. We simply build that project. We can save it later, but let's just build it and see what happens. SmartAssembly is helping us out here. It's saying, okay, I've built your assembly. What would you like to do? Would you like to test it out by running it, or perhaps just see what the results are? It's very useful because when you've got these different versions of your application, the built version and the protected version, it gets a little bit confusing as to where things lie. So SmartAssembly is helping you out here and showing you exactly where it lies. It's always best practice to test your assembly just after you've added a new feature, because that will help you understand the nature of your application after it's been obfuscated. Let's just check that that's working. Looks okay. There we go. You might be thinking at this point, how do I integrate SmartAssembly with my build environment? Maybe how do I auto-test it? Well, I'll touch on that subject. I won't go into great detail. As I say, I work on the support department. You can always contact me directly there. You should have my email details, or we can give that to you. But in summary, we now have a perfectly working protected version. Just to recap, let's look at the project settings. Well, I've just got strings encoding enabled. You'll see over here, this is green as well. This is green out of the box. It's just a way of generating a PDB for you. let's take a look at my newly protected application. Okay, there's some differences here. SmartAssembly's added some code, and this is what it uses to decrypt those strings. And there you go. My strings in plain text have simply been replaced by hex values. Even in the intermediate language, that's what it's done. So there you go. That will potentially give your application a lot more security. But the real headline feature of SmartAssembly is this wonderful thing called obfuscation. Obfuscation and encryption are very closely related, but it's important to make a distinction because you need to be very aware of the power of one over the other. You need to be aware of the potential attacks in all cases, and in obfuscation and encryption have very different properties when it comes to the attacks. The main difference between obfuscation and encryption is that encryption needs a key to reverse engineer. If you use the latest algorithms such as AES, or also known as Raindale, or DES, triple DES, even though that's an old algorithm, it's perfectly good. If you use those kind of what's often called military grade encryption, you'll still need a key to encrypt and decrypt. So that's good, but you don't want to be distributing your keys, do you, to customers. That model never really works. So obfuscation tries to protect your application as well as encryption without needing keys. And how does it do that? Well, it basically introduces some random factor into your code, and still works as well, because the important information in your code is usually human readable. That's often where the IP is, trying to understand how you coded your application. You need a human to do that usually. So if you can interrupt that process, if you can make it much harder for a human to read, that's as good as encryption. And that's exactly what obfuscation does. Let's take a look at it. Again, one way that SmartAssembly helps you navigate this process is you simply click on these different icons. There's an awful lot of information here, but helping you navigate is that simple process of identifying the icon. We put a lot of thought into these icons just for that purpose. So out of the box, you can see this strip is yellow, so warning bells should be ringing. And what that means is it doesn't automatically say, yeah, go on, here you go, obfuscate your application, just press build. It needs a little bit more interaction than that. And the reason is because you might be using SmartAssembly for the different features, even orthogonal features that are not to do with obfuscation. Okay, so don't make any assumptions. The UI is trust it to be intuitive, because as you can see, now it's green, so that should be a good enough clue for you to realize, okay, I've enabled it. And conversely, look out for it being yellow, because that means you may have forgotten to simply click that box. Okay, so there you go. I'm going to obfuscate my main executable. You have a further choice as to the power of obfuscation. I'll talk a little bit about that later, but just for the purposes of this demonstration, I'm going to use ASCII so you can more clearly see what's going on within Reflector, within the reverse engineered aspect of this. Let's quickly test it, see if it runs. I'm just going to look for an OK here. Yep, that's OK. Good. I can't emphasize enough that you really should test your applications after, maybe not after each feature, but as soon as you've settled on a feature set, make sure you test it. And let's see now what that looks like in the protected version. I'll show you what it looked like before, so that'll help. So here we are. my main executable is still perfectly reverse engineerable, except I just change the strings around. Let's see what it looks like now. Okay, so there we go. Whereas I could drill down into my namespaces and my methods, I can't easily do that now. This is all no longer human readable. So even to find my main method, take a look, takes some doing. There we go. So there we go. That took me a while to find that because it's no longer human readable. So it's changed my namespaces and my class names, and it's also changed my method names as well. But as you can see, it's still perfectly readable at this level. So that's a clear distinction between what obfuscation does and what you might intuitively actually think about encryption and full obfuscation, full protection. You might be thinking, well, this isn't any good, is it? Well, you're absolutely right, but I'm going to explain how we can get back into that full encryption. But I just wanted to be absolutely clear that this feature, what's traditionally known as obfuscation, is really about changing the names of your types and your methods and your fields, also called name mangling. That's the clear definition of that. So that's 2 out of 3. What really completes all the essential features is this next option called control flow obfuscation, and that gives you a clue as to what it does. Let's see exactly what it does. Again, we have the choice of different levels of obfuscation, and I'm going to explain that now, and the reason why I'm going to explain that now, it's a little bit easier to explain with this feature than obfuscation, although exactly the same principle applies. So as you can see here, level 2, a perfectly sort of decent amount of obfuscation will support mono. But if you went to the very strongest level, you would actually break some of the mono specifications. So this gives you a bit of an idea as to why it's a bit of an art, obfuscation, because if you think about what it's doing, it's taking your intermediate language and it's effectively having its wicked way with your intermediate language. You're giving it a license to do practically anything with your code. And the skill of the application writers is to work within the boundaries of certain specifications, the CIL specification, push those boundaries, sometimes even break those boundaries in order to make your intermediate language just completely reverse engineerable. And excuse me, and in this case it will break, the strongest application of this feature will break mono. And another example might be working in the SQL Server .NET environment that actually has stricter specifications than the general environment. This is why I recommend testing as much as possible, because sooner or later your assembly may go into a more restricted environment than you usually test with. Okay, but we're going to go ahead and we're going to use the strongest power of this feature, just to show you that it works perfectly well. And this time I'm going to save the project because I've put quite a lot of effort into it now, so I want to save it. And we help you out by giving a default name. What I recommend is, while you're testing out SmartAssembly, start to build up a small library of SmartAssembly projects and give them a good name. And this one I'm going to call like All Essentials. So the three features we used, general obfuscation, control flow obfuscation, strings encoding, I'm saying that those are really the essential features that you'd like to use, you really should use for all your projects. Those are the core ones. So that's that. Let's build it, test it of course, and then look, so let's see what it looks like. Okay, that's okay. I'll show you the before and after. This is before. I can't read the strings, I can't read the method names, but I can read the code itself. Let's see what control flow obfuscation does for me. Okay, so this is exactly the stage that we want to get at, where not even Reflector can reverse engineer your code. It just gives up. It tells you the code is obfuscated, it cannot be translated. Let's see what we can do in intermediate language. Well, as I said, Reflector doesn't actually do anything that clever when it comes to looking at the intermediate language of your assembly, because it's a one-to-one mapping between what you see here and your assembly, because your assembly is intermediate language. But what's actually gone on is there's a lot more of it now, because what control flow obfuscation does is add lots of jumps, lots of labels and go-tos in your code, so much so that it becomes absolutely impossible for a Reflector to interpret that correctly. And so it doesn't even bother, it just gives up, because if it tried, it would crash. So here we go with some branching code. These are the jumps that control flow obfuscation puts in. So those, let's review the situation. Those settings, the three we've gone through, are the most important features to always add to any obfuscation project. So on to the slightly more advanced features. A natural follow-on is, well, what about my dependencies? What can I do with them? And it becomes even more of an art to getting the right compromise between full features but not affecting your assembly when it comes to third-party applications. There's a set of general rules that I apply with this, and often ask yourself the question, which assemblies are essential to protect? It's not going to be essential to protect your third-party applications generally, is it? There's an argument for doing that, but think about the most important part of your deployed application, and that's your own IP. Having said that, the way to go about protecting your dependencies, whether they're third-party or not, is a nice little feature we've got called merging. As the name implies, what this does is literally take intermediate language from one assembly and IL from the another and merge them together so that they literally become the same namespace, the same assembly effectively. That has some dangers because you're changing the namespace, but it also has some very nice features in that any assembly you merge into your code inherits exactly the same protections that you've just given your main executable, because it is effectively now the same as your executable. That's what merging does. It makes it the same. So this is something you might go to next when it comes to protecting your application, because it has a nice effect of simplifying the deployment of your application. So let's go ahead, select all. These are my third-party DLLs that help me write the application. I'll build that and test it, make sure it works. That's all okay. And let's see the effect. This is the before. Now ask yourself, what would you expect to see now after given what I've said? What I've said is, remember, I'm going to now merge my dependencies into one single executable. And we're going to see what it looks like now. Well, from this level, it doesn't look very different because it is the same. Okay, and it works fine. It looks the same, and it has the nice feature now of not being dependent on any more separate files. You can now distribute your application as is, and that works just as well. So these are the nice features with things like merging. Makes it easier to deploy your application. It's all self-contained now. You shouldn't have any version issues ever. But the thing I have to follow this up with is merging doesn't always work. As I say, it's quite a dramatic thing it does to your code by changing the namespaces. It's really not generally going to work in any kind of reflection environment or where you're relying on the hard-coded namespaces. So the thing to do is test it out. If you get any problems, the immediate thing to do is just reverse that feature, and instead of merging, use the equally useful but slightly less dramatic feature called embedding. And what this does is literally take your assembly, package it up as a encrypted and compressed resource, and then squirts it into your application in that way. So it maintains its outward properties, its namespaces, but it doesn't quite integrate as well as merging. It's a pretty good compromise, though. I do recommend it. And finally, let's just make sure that works. That looks okay. So really, of the more advanced features, the next thing to look at are merging and embedding. And finally, what I want to show you is what happens when you put all of them together. Does it still work? Okay, so what I did there is I'm now putting on the very first of the advanced features, strong name signing, with our new feature, tamper protection. I'm not going into any great detail about these other features. You can test these out yourself, but I just want to prove that it can work with all features selected. You can see just how many different options you get with SmartAssembly. As you can see, when you start to merge your third-party assemblies, you then get the option to obfuscate them as well. There you go, all green. He's happy. Thank you.
So that was it for the actual demo. So thank you very much, Chris, for doing this. Before we go over to Q&A, I just wanted to let you know that if you're interested in actually using the tool on your own app for yourself, we do offer a 14-day free trial of SmartAssembly, which you can get from our website. And also, if you would like to speak to someone about the tool, just drop an email to John Hudson. His email is on screen. He'll be happy to help, or Chris. And if you're interested in buying the tool, John will be offering all the webinar registrants a 10% discount until the end of May. So you just need to sending an email with the code that you see on screen at the moment, and he'll take care of this for you. So thank you for attending, and thanks to Chris again for presenting. And now we'll end with the Q&A. And if you type any questions that you have in the GoToWebinar panel on the right-hand side of your screen, we'll attempt to answer them now. So, Chris, I had a question earlier from Klaus, who asked, could you talk about the problems of obfuscation and reflection? So when somebody wants to use reflection. So I'll just hand over control to you. Just give me a sec. There you are.
Right, thanks for that question. So as I hinted at before, there are some issues sometimes with obfuscation, especially any technology based on reflection. I have an example. I'll see if I can show that quickly, and if not, I'll just talk about it. The general problem is, of course, that reflection relies on metadata, and it relies on name binding, both of which will be affected by SmartAssembly and obfuscation generally, whichever product you use. SmartAssembly tries to do its best to automatically recognize the methods that are relying on this technique. For example, if a method is marked as serializable, it will ignore it in the obfuscation. But there are cases where it's very difficult to work out automatically what the issue is. Let's see if I've got that example to hand. So I've got a simple WPF application here, and the issue here is a similar one. It's the fact that WPF relies on name binding in order to work, and that obfuscation will break that. I've got a broken and a fixed version. Let's see if I can. Okay, so that's the broken version. And I'll just do that again in the context of SmartAssembly. Okay, so here we go with the SmartAssembly project that's only been selected for obfuscation, and it's the same one as that I showed you before. Let's see what happens. It's giving me some nice helpful feedback here. It's recognized that I have dependencies in other folders, so naturally I want them copied over to my output folder. Okay, so that works fine. So let's see a feature that actually breaks that now. So recapping what I said, that let's put in the essential features and then think about some of the advanced features. That's fine. I'm just going to do this simply. And then the next thing to do is test out to see if merging works. Okay. Okay, and here we go. It didn't work because, as you saw, I added merging into the feature set, so that's breaking something. This is a SmartAssembly generated error report, something I didn't go into detail about, but please download a program, test it out, and just convince yourself that this is a useful application, useful feature. But it's been useful in this case because it's telling me exactly what the issue is. So I'm not going to send that. Let's go back to our settings and remember what I said, that if merging doesn't work, try embedding. Let's see if that helps. If this works, excuse me, wrong one. If this works, have a think about why in that case. As you can see, it has quite a clever mechanism here that if all my dependencies are selected for merging, I don't have any embedding options because it's one or the other. So if I clear that, I now have these options. So as I say, if this works, have a think about why in the context of name binding. That's okay, that works. And the reason is because, as I say, merging creates a single namespace in your application, and that of course isn't going to work with name binding. This was a classic WPF example. The same kind of thing applies in many reflection options as well.
Okay, thank you, Chris. So I've got another question here asking, how does control flow obfuscation affect performance?
Okay, so this is something I can quickly talk about. It's a very good question because of all the features that SmartAssembly uses, control flow obfuscation we recognize can have effect on performance. We've never ever known it to be, for example, a production issue. No, I don't have any support tickets that say I've used it and now it's unusable. And in our experience, using the highest power, as I say, you have different settings, different levels of control flow obfuscation. And we would say that maybe a pathological worst case scenario is something like 10% performance loss you may see using the highest value. But as I say, we've never had any support issues where it's been a sort of life or death thing, a deal breaker. And the reason why we have these different levels is because if you've pushed the envelope a little bit too far in whatever way, just take it down a notch. As I say, it's a bit of an art finding it out, and only really you know what the right thing is, because only you have tested your application well enough, haven't you?
Okay, brilliant. So we've got more questions coming in. I've got one from Gordon saying, how easy is this to embed in a TFS build? Okay, so I'm actually going to hand over that one to our SmartAssembly lead developer who wants to answer this one.
Hi there, everyone. So I've never actually used TFS myself, but I imagine since it's a build system, it has the capability as part of the build to just run, to just build your solution. I'm assuming that. In which case, it's very easy to integrate SmartAssembly into the normal build that your solution does. You have two options, really. First, you can use a post-build step. So in Visual Studio, in the project properties, there's a tab inside there for adding pre- and post-build steps. You can add a post-build step to SmartAssembly's command line interface, which just lets you do smartassembly.com is the name of the command line executable, and then you pass in an existing project file that you've used. Chris is going to open the project properties so we can see that happening. There we go. There's a great example. So if you do that, then Team Foundation Server will just obey that and do what it needs to do. An alternative, I actually like the second alternative better, is it involves actually opening up your CS proj file in a text editor, but is slightly nicer in that it doesn't start so many command line processes. What you can do is add this is available if you just Google, you'll be able to find the explanation how to do this on our support website. You can add a SmartAssembly MS build task to the end of your build. Perhaps we'll be able to Google that for you now, and that will run equally. Oh, there we go. We've got it open already. So if you use either of those two options, you'll be able to integrate it with your TFS build.
Okay, thanks very much, Alex. I've got another one from Klaus saying, can I serialize classes being obfuscated?
Back to Chris again, because I feel confident enough to answer this, but I might have to hand back to Alex if it gets a little bit hairy. It's another very good question, and the answer is yes, but you do have to do some extra work. You effectively have to define the metadata of your serialized assembly. Yeah, this is where I have to hand over, but it is possible, and we'll help you in support. But here's the full answer.
So there are two ways to have a serializable class. Either you can have the serializable attribute, in which case .NET will do the serialization automatically for you. Now SmartAssembly will notice that, and it will see that if it started obfuscating the parts of your class, then that would start failing. So SmartAssembly then doesn't obfuscate that class if it's got the serializable attribute. But if it was important for you to obfuscate the class, then you can instead implement iSerializable, which is .NET's alternative way of doing serialization, which will let you implement, I think the name of the method is getObjectData or something like that. And then if you implement that manually, SmartAssembly will notice that, okay, now he's implementing it manually. You don't have to stop the class from being obfuscated.
Brilliant. Thank you very much, Alex. Got one last question on control flow obfuscation, actually. I forgot this one. How does control flow obfuscation affect the garbage collection?
The short answer is it doesn't at all. The garbage collector won't be affected by control flow obfuscation.
Okay, thanks very much, Alex. So anybody else got any other question, or shall we leave it at that? Okay, so I think we'll leave it at that. We've got with 5 minutes to spare. That's pretty good. So thank you again for attending. Really appreciate it. Thanks to Chris for the demo, and thanks to Alex for helping out with the questions at the end. That's really good. If you can think of any other questions that you would like us to answer, just drop me an email, and I'll make sure that somebody gets back to you, either Chris or Alex or somebody in our sales team. Thank you very much, and have a good day. All right, bye.